In the previous lesson, we learned about circumference and area. In this lesson, we're going to contrast circumference and area. That means we're going to take a look at the difference between the two ways of measuring a circle, circumference and area. We're going to start with a warm-up. What do you notice? What do you wonder? Pause the video. What do you notice? What do you wonder? I notice a bunch of cheese puffs on a baking tray, and on top of the cheese puffs, there's a plate. And then on top of the plate, there's another cheese puffs. And I also notice the plate's a circle. And the cheese puffs are, they're actually not a circle, they're a sphere, because they're a three-dimensional circle. So I notice that the cheese puffs are a sphere, and the plate's a circle. About how many cheese puffs can you fit on the plate in a single layer? It's more like area than circumference. So how many cheese puffs can you fit in that space over the plate? Maybe if you have going across, maybe I have 8 diameter, and going the other way is 8, so maybe like 15 or 16 cheese puffs. That's the diameter, and then area is pi r squared. So diameter is about 16, the radius is 8, 8 squared 64, so 64 pi. That would be the area. And how many cheese puffs is that? 64 times pi, which is about 190. The first activity is called card sort circle problems. And this card sort is in the Schoology folder for today. Click on the card sort Google Slides and open the Google Slides, make a copy. And what do we do for the card sort? Sort the cards into 2 groups based on whether you would use circumference or area to solve the problem. So let me open the card sort. So this is our card sort. And let's start reading the questions. How much fabric is needed for a round tablecloth? That is area, because we're talking about the fabric. How much fabric is needed for the round tablecloth? You need to figure out the area, how much area you need to cover the table. Question 2, how fast do you go when riding a Ferris wheel? When riding a Ferris wheel, you go on the outside of the circle, so that would be circumference. Question 3, how much green space is there inside a traffic roundabout? How much space inside, that is area. Question 4, how many square inches of cheese fit on a slice of pizza? Circumference is one-dimensional, and this question is asking about square inches, so that's area. Area. And question 5, how many times must a horse go around a horse walker to walk 1 mile? Well, that's around the circle, so that is circumference. Question 6, how many feet are traveled by a person riding once around a merry-go-round? That says around, and they're walking around the merry-go-round, so that is circumference. Question 7, how much room is there to spread frosting on a cookie? That is area, because we're talking about the area on top of the cookie. Not the outside of the cookie, but on the cookie itself. And then question 8, how far does a unicycle move when the wheel makes 5 full rotations? Well, rotations, and we're talking, usually when it says around or rotations, it's talking about around the circle. On the outside of the circle, so that's circumference. For the next activity, we're going to analyze circle claims. We will look at 2 students' answers to 3 different questions. For each question, you're going to decide if you agree with either one of them. Explain or show your reasoning. The first question is, how many feet are traveled by a person riding once around the merry-go-round? Claire says the radius of the merry-go-round is about 4 feet, So the distance around the edge is about 8 pi feet. Andre says the diameter of the merry-go-round is about 4 feet, so the distance around the edge is about 4 pi feet. Pause the video. Is Claire correct or is Andre correct, and why? For this problem, Claire and Andre are both correct about the calculation. However, there's something that they differ in, and that is their measurement of the merry-go-round. So Claire is saying that the radius is about 4 feet, and Andre says the diameter is about 4 feet. Who do you think is correct? You think Claire that says the radius is 4 feet, or Andre that says the diameter is 4 feet? Well, if you look at the picture, that little girl is probably closer to 4 feet. So you could probably fit about 2 or 3 of her on that merry-go-round. If she were to lay down and there were her friends, they would go from one end of the circle to the other. So the radius is about 4 feet, not the diameter, which means Claire is correct. The radius of the merry-go-round is 4 feet, and so the distance around would be closer to 8 pi feet and not 4 pi feet. Question 2, how much room is there to spread frosting on the cookie? Claire says the radius of the cookie is about 3 centimeters, so the space for frosting is about 6 pi centimeters squared. Andre says the diameter of the cookie is about 3 inches, so the space for frosting is about 2.25 pi inches squared. Who do you agree with and why? In this case, their measurements could both be correct, because Claire and Andre, it's about the same. If the radius is 3 centimeters, the diameter could be around 3 inches. But this time it's their calculation that's different. So I agree with Andre. The reason for that, Claire says the radius is 3 centimeters, so the area is 6 pi, but it's pi r squared, so it would be more like 9 pi, and she says 6. But according to Andre, the diameter is 3 inches, which means the radius is 1.5 inches. So the space for frosting could be about 2.25 pi inches squared. Question 3. How far does the unicycle move when the wheel makes 5 full rotations? Claire says the diameter of the unicycle wheel is about 0.5 meter. In 5 complete rotations, it will go about 5/2 pi meters squared. Andre says, I agree with Claire's estimate of the diameter, but that means the unicycle will go about 5/4 pi meters. Who do you agree with and why? Pause the video. So in this case, without even doing any calculations, I would say Andre is probably closer because he is using meters and not meters squared. They're talking about rotations, and meters squared is a two-dimensional. That's an area measurement. So I would say Claire's measurement's completely wrong because she's using meters squared, and Andre's using meters, which is one-dimensional, and diameter is measured in 1 dimensions. So 5/4 pi meters. But think about his calculation because he could also be wrong. So let's see if his calculation, it makes sense. So they both agree the diameter is about 0.5 meters, which is 1/2. That's the diameter, which means the radius is 1/4. A fourth is 1/2 of a half. And that means, so he says the unicycle will go about 5/4 pi meters. So let's see what the circumference would be in that situation. Circumference is 2 times pi r, which is 2 times pi times 1/4. That's also pi times 1/2, which is 1/2 pi. 1/2 times pi can be simplified as pi over 2. But if you read the problem, they want to know how far the unicycle moves when the wheel makes 5 full rotations. So it's 5 times pi over 2. In 5 full rotations, I'm going to use a different color. It's 5 times pi over 2. Usually you can simplify that to 5 pi over 2. And that is not the same thing as 5/4 pi or 5 pi over 4. So neither of them are correct. Claire does have the correct calculation, but she used meters squared. Meters squared. That's an area measurement. That's for in 2 dimensions. When you're using squared, it's for area, not circumference. Lesson synthesis. When would we need to calculate the circumference of a circle? Well, we saw a number of questions that require the circumference of a circle. A lot of times they use it in physics when they're measuring how fast the wheel is spinning, because you're using the outside of the wheel and how much ground it could cover. So how many circulations or rotations is the wheel spinning? When would you need to calculate, let me put a check mark here. When would you need to calculate the area? The area would be if you want to cover the space in the circle, such as if you're putting frosting on a cookie. What do you need to know to estimate or calculate the circumference of a circle? Well, that you need to know pi. For that, you need to know the diameter or the radius. Once you have the diameter and the radius, well, you can have one or the other. You don't need both. So if you have a diameter or radius, you can figure out circumference, you can figure out area, you can figure out a lot with the circle. And for the radius and diameter, a lot of times you just need to measure it. What do you need to know in order to estimate or calculate the area of a circle? Again, I would say same thing, either radius or diameter. Cool down. A circular lawn has a row of bricks around the edge. The diameter of the lawn is about 40 feet. Which is the best estimate for the amount of grass in the lawn? Which is the best estimate for the total length of the bricks? Pause the video and try this problem yourself. The diameter is 40 feet, so the radius is 20 feet. And the radius goes to the outside of the lawn. Doesn't include the bricks in this problem. I don't think it really matters in this situation because these numbers are so different. And you should, but it maybe in another situation it will matter. So which is the best estimate for the amount of grass? That is, I'll use another color here, but the amount of grass, let's do green for grass. That's an area measurement. Area. And area is pi r squared. In this case, 200 squared times pi. So 200 squared is 400 pi. Is 400 pi closer to 125 or is it closer to 1250? It's closer to 1250. And we're in area, so that's squared feet. So for number 1, closer to 1250. I didn't even, you don't even need to do the calculation, like how much it is. There's only 2 options, 125 or 1250. So 200 squared is 400, and that's 400, the area is 400 pi. So 400 pi is definitely closer to 1250 than 125. And number 2, which is the best estimate for the total length of the bricks? Let's use red for bricks. And that is circumference. circumference. And circumference is one-dimensional measurement, and 2 pi r, which is 2 times 20 r pi. So 40 pi, which is closer to 125. So it's this one. And again, circumference is a one-dimensional measurement, so it is not measured in square anything. It's just a unit of measurement, such as feet. Here are the learning targets for this lesson. I know whether or not the relationship between the diameter and area of a circle is proportional, and I can explain how I know. I can explain how the area of a circle and its circumference are related to each other. I know the formula for area of a circle. I can calculate the area of more complicated shapes that include fractions of circles, and I can write exact numbers in terms of pi.